This is for Math 9, 1.1. We're going to look at this first question. Is 0.081 a perfect square? So first thing to think about is that decimals are hard to know if they are perfect squares or not, because then you need to take the square root to find if it's a perfect square. So we're just going to talk this through. So when it asks, is this a perfect square? It's asking for a square of area 0.081, is it a perfect square? And remember, in class we talked about the side length being the part that we look at to find out if it's a perfect square. So if the side length is a nice number, then it is a perfect square. And if it's an ugly number, then it's not a perfect square. Okay? So basically, nice numbers are rational numbers, ugly numbers are irrational numbers, which we'll talk about more in class later on. But basically, ugly numbers are decimals that repeat, or that don't repeat, that just keep on going, and you never really know what the next number is. Nice numbers are any sort of fraction. 1/2, or a stopping decimal, or a repeating decimal. The line on top. Okay? So we've got ugly numbers, we've got nice numbers, but it has to do with the length of the side. To find out the length of a side, if we have the area, we have to take the square root of the area. So I'm going to give you a little formula here, but we can just remember that the side length equals square root area. Or you can remember the previous formulas that you might remember. Area equals length times width for a rectangle, and for a square, it's just length times length, which is the same thing as writing length squared. So area equals length squared, which we're going to get to a little bit later, but the inverse operation of a square is a square root. So when we do the inverse operation of this one, it moves us to this one. So those two are the same. So a length equals a square root of the area. So we want to figure out if the length is an ugly number or a nice number. So we want to take the square root of the area. So our area is that, and we could just plug it into a calculator, but we're going to be practicing without calculators, and on tests we're going to be not using calculators. So we need to make this number a little bit easier than 0.081. To do that, we're going to put it as 0.081 equals 81 over 1,000. So this is tenths, hundredths, thousandths. Okay, so 81 over 1,000. Now, if we take length equals square root 81 over 1,000, it's a little bit easier, but still hard. But now let's look at this. Square root of 81, square root of 1,000. Is that doable? Is that a perfect square? Okay, so square root of 81 is 9. Square root of 1,000 is not a perfect number, right? So let's think about this. If it was square root of 100, then we know it's 10. 10 times 10 equals 100. Now, if it was square root, or if we did 100 times 100, then we'd have to have square root of that many zeros. So this bottom here is going to be some sort of number, oops, a little bit less, some sort of number that's bigger than 10, less than 100. We don't know what it is, but it's going to be some sort of repeating decimal down here, and it's not going to work. It's going to be an ugly number. Okay, so we kind of figured that one out. Let's move down here, and hopefully we can have a nicer time with it. Calculate the number whose square root is 5/6. And just to sort of remind you, these are basically the only two questions you get for this topic. Is it a perfect square, or you're doing the square root, or calculate the number whose square root is 5/6. Now we just talked about this here inverse operations, and if we talked about it as inverse operations, then we know it's asking calculate the number blank that if you square root that number, you get 5/6. So if we talked about it as inverse operations, then to do that, we actually just need to flip it and ask, what is 5/6? And we want to square the whole thing, equaling some number. Okay, so calculate the number whose square root is that. You have to just square the number that it just talked about. So that doesn't seem very easy quite yet, but in very similar way as up here, how we can break up the square root from top and bottom, we can do that here. So we're going to do that and have 5 squared over 6 squared. Makes it a little bit easier because 5 squared, if we remember our times tables, and now we sort of have a square table. Sorry, 5 times 5 is 25, and 6 times 6 is 36. And this here is our new fraction to give us sort of the area of our square. So basically, in terms of what we're thinking about here, we were just given the length, and it was asking for the area. And so this new number here, you want to think about it more physically, this is the length, whereas this was the area. Okay, I hope this video helped you, and good luck on the homework.